Welcome to another API Spotlight. The goal of this video is to cover the standard logging facade, also known as SLF4J's API. One of the very first things that most people learn with programming is how to output text to the screen through standard out, in this case using system.out.println. Here you can see an example where we want to track the state of our program and see which fruit it is processing one at a time. While using standard out in this way works well for small programs, as your programs grow in size and complexity, it oftentimes is hard to find where prints are called without resorting to searching the entire code base. This problem gets worse when you consider libraries that you are consuming. These also need to provide log statements, as they're called. However, sometimes these statements are more verbose than you want to see in your program. In this case, it would be helpful to be able to turn off those log statements, but using just a simple system.out.println that isn't possible. Logging APIs were created to solve this problem. They let you log messages at differing levels of granularity and allow for configurations at runtime to filter down the messages that are produced. Some common logging APIs include Java util logging, Log4j, and Apache Commons logging. This list is by no means exhaustive, and many more logging APIs exist in the Java ecosystem. This created a new problem where you need to have and configure every logging API that is used by each of the libraries that you want to consume. To solve this problem, SLF4J was created. Its vision is to create a single logging facade that allows for using any logging backend that the end application wants to use. To use it effectively, you need to use SLF4J everywhere that you would normally call log statements. This enables the flexibility that the library provides. With those details on the purpose of SLF4J out of the way, let's get to the API. Here you can see the most common use cases that programmers will use the library for. You define a logger at the top of each class, passing in the class as its name. For each log statement, you call the method correlating to the log level that you want to log at. In this case, we're logging at the info and debug levels. One nice feature that SLF4J provides is being able to pass parameters into a string using the double curly brace syntax. The main reason for this versus using a format string or direct string concatenation is performance. SLF4J has created its own templating API that is about 10 times faster than Java's string format API. The lack of string concatenation also allows for much faster performance in cases where log statements are skipped. SLF4J defines 5 main log levels that applications can log at. These are trace, debug, info, warn, and error. The interpretation of these levels is up to the developer of the application, but typically info is the default level that is logged by loggers without changing configuration files. Further exception stack traces can be logged by passing in the exception as the last parameter to the logger when no format specifiers are present. With the new SLF4J2 changes, you can additionally use the new Fluent logging API, which allows building up log messages. To start, you specify the log level that you want to log at, and then you add each argument that you want to provide to the log statement. Finally, you call the log method with the log statement that you want logged. This also allows for passing in Lambda methods to the API for values that are time-consuming to acquire and shouldn't be grabbed unless the log will actually be produced. For further information about SLF4J's API, there are links provided in the description below. If you found the information helpful and want to see more videos in the future, please comment down below on which APIs you would like covered in future videos. Thank you.